So how's this radical chapter been going for you? It's pretty challenging, isn't it? But do you remember all the crazy radical things that we've learned? Graphs and transformations. Rational exponents. Root A times root B equals root A times B. Rationalize the denominator. Multiply the top and bottom by how much more root. Properties of exponents. When multiplying, add them. Radical operations. You need like terms. It's time for something easier for a change. Well, I've got just what the doctor ordered. To finish the chapter, we're going to learn how to solve radical equations.
All this talk about radicals it's been challenging, but I think you'll find that this last lesson, solving radical equations, when compared to the other lessons, is a little easier. Now, I didn't say it was easy, but just when compared, it's a little easier. We have some knowledge of solving equations. You've even solved equations a little bit that have had some radical signs in them. And so why don't we use this as a good opportunity to just kind of remember some good algebra. Now, when you solve an equation, it's like an artichoke, right? You have to peel it off layer at a time, and you always want to peel off from the outside to the inside. And really, your goal is always to isolate, but I'll say that first your goal is to isolate the radical. Your goal is to isolate the radical. Now, I'm saying that because the first thing you really want to focus on is any numbers that are on the outside of this radical. They would be like the outer layer of our artichoke. And of course, it's the 5. And that 5 is being multiplied, so we want to do the inverse. We want to do the opposite. We want to divide by 5. Now, after you divide by 5, you kind of get yourself to the next layer. The next layer being a cube root of this 4x plus 3, now equaling 3. Okay, now the radical's been isolated, so now it's time to deal with the root itself. And what you want to do is you want to power away. You want to power away the root. And when we power away the root, what we're talking about is using a power that's going to cancel with this 3. And that power is going to be a power of 3. So we raise both sides to the third power. Okay, now again, that cancels with that root. That means that the radical sign is gone. It's not a square root anymore. In fact, it never was a square root. It was a cube root, but it's not a root anymore. It's just 4x plus 3. Now, 3 to the third power, well, that's equal to 27. And anytime you're looking at something like 4x plus 3 equals 27, keep in mind that you still want to simplify and solve. Basically, you want to finish the problem. And this should be pretty easy finishing because, of course, we're going to subtract 3. And when you subtract 3, you get 24. And then you can divide by 4. And we can see that x equals 6. Now, that's a decent problem. We'll do some that have some other bells and whistles, but we're not quite done with the problem because there becomes this step that kids don't always like, but I hate to tell you, if we want to make sure we have the final answer correct, we have to think about checking that for what's called an extraneous solution. Now, an extraneous solution would be like an extra solution, or really it's a false solution. So how do we know if x really does equal 6 is kind of what I'm suggesting here. Well, you can plug 6 back in. Now, when you plug 6 back in, you'd be plugging it back into the original equation. So maybe it would be helpful here if we start jotting down the original equation. Now I'm going to plug 6 in. There, I plugged it in beside the, I plugged it in for x. And we're trying to see if this equals 15. Now, you might be saying, Ms. Neller, why? Why do I have to check my solution? Well, it turns out that when you do radical things, when you do steps that involve a radical, that even though you might do all the right work, you might end up creating something that is not true. Okay, now we get ourselves down to the cube root of 27. And the cube root of 27, we've done that a couple times, actually more than a couple, but that is a number that multiplies to be 27, and it has to be the same number. and it has to multiply 3 times. And of course, that would be the number 3. So it turns out that we do equal 15. So that means that x equals 6 is the solution. It's not extraneous. Are you ready to look down at this radical equation? You always want to isolate the radical. That means any number that is outside of that box, you got to peel it away. So subtracting 6 is pretty easy and definitely the right thing to do. Now when you do that, you get -5, and then you want to get ready to power this away. Now this is a square root, so I'm going to raise both sides to the second power. Make sure that you're actually squaring -5, and that leaves you with +25, so that when you add 3, you can get 28. Or do we get 28? You see, you have to check for an extraneous solution. So whether you kind of like this or not, I realize that it's a little extra work. We have to plug 28 back into the original problem and see what happens. Now, it turns out that what happens is that we get the square root of 25. Now, the square root of 25 is 5. And, well, that doesn't equal 1. That equals 11. So we could say that this does not work. Now, if we were in class, I would imagine that somebody might say, wait, Mr. Naylor, the square root of 25, that's plus or minus 5, right? Plus or minus. Isn't the minus going to work? It's not that we have a plus or minus here, and the simple reason is because the problem originally started with a plus sign. Honestly, if we wanted it to be a minus sign, we would have made this a minus right here. But that's not the way that the problem started. The problem started with a plus sign. You say, but I thought it was always plus or minus. Plus or minus is if you're solving an equation and you introduce a square root. If I solve this equation, now I introduced a square root, and that's going to give me plus or minus my answer. But for this problem, what I want you to understand is that the square root was given to you. And not only was the square root given to you, but it was a positive that was given. So you got to take what you're given. And the bottom line here is that 6 plus 5 does not equal 1. And what that means is that 28 is actually not a solution. Often we will cross it off. We can also write the word extraneous beside it. The bottom line is that 28 is not a solution to this problem. Do you want to try number 2? It's a good problem to try. You can push pause. I'll meet you back here in a moment, and we'll work out the solution. So how'd you do? You want to isolate the square root. That means that that 2 that's out there has to get divided away. That would be your first step. Be careful. Don't try to subtract 1 as your first step. You can't get inside of that artichoke without pulling off each layer at a time. So I end up with a square root equaling 7, and I just want to power that away. So we square both sides, and that should give you 49, which of course eventually gives you 48 for x. Or does it? Is 48 really the solution? Well, a careful check when you plug 48 back in, you find out that you're going to be adding you're going to be adding to 1, which gives you the square root of 49. And a little bit more simplifying says that 2 times 7 does equal 14. So 48 is the solution. It's not extraneous. All right, you ready to flip over to the back? Just a few more problems to do, and a little bit more interesting. We kind of have a little Lego guy panic here. Let's see if we can turn that panic into a smile, but we'll work through carefully each of these three. These 3 problems, you might say, they kind of have some special thinking. Not necessarily that they have to be hard, but they do take some careful attention. Now, the radical is already isolated here, so I don't need to do something like subtract 18, but rather I want to jump in here and I want to square both sides. But when you square the right side, you have to square it as a quantity. So remember, squaring a quantity is going to require the FOIL method. Okay, so we do want to carefully square both sides, but especially squaring the right side, we want to think of this as really x minus 2 times x minus 2. Now, again, that's the FOIL method, so no math teacher nightmares. Rather, how about an x squared minus a 4x plus a 4. Now, when you square the left-hand side, you get a nice little cancellation, so you just get x plus 18. Now, this equation is a little different, isn't it? It's got this x squared. I hope that that catches your attention. It's been a little while since we've dealt with this, but this kind of equation is asking you to set it equal to 0, right? You want to set this equation equal to 0. So subtracting x and subtracting 18 is definitely the way to go, because what we have now is an equation that is of a special form. And that special form, if you're not sure of the name, it's a form that's known as quadratic. So when you have a quadratic equation, you always want to finish that by finish a quadratic equation by solving it when it's equal to 0. Again, we have to make this equation equal 0 so we can finish solving it. Kind of wondering what method you're thinking here. With everything we've talked about this year, you know you could use the quadratic formula if you had to, but maybe we can just factor. And factoring's nice when you have two numbers that multiply to be negative 14 and add to be negative 5. So I would say factor this thing. It's so much easier to find your solutions to be 7 and negative 2. Or are they? Now, this is where we have to be willing to check our answer, because really what you have to do is you have to plug in 7 and you have to plug in negative 2. Now, you don't want to plug them both in at the same time. You actually want to plug in each of them individually because they are both separate answers. So it looks like I end up with the square root of 25, and okay, that's good. A lot of times what people do is they'll circle that answer because that shows that it was checked and that it works. What happens if you plug in negative 2? That's going to give us, it's going to give us the square root of 16. And the square root of 16. Now, this isn't plus or minus the square root of 16. This is just, it's actually plus the square root of 16 because that's the way the problem is given. So yeah, that does not equal. That does not work. So I would have to cross this one off and realize that my only answer is x equals 7. How about a problem that's got two radicals? Two radicals. Now, the rule of thumb was you were supposed to isolate a radical. But the problem here is that if I put a box around this, it's not isolated because there's another radical beside it. And if I put a box around this, it's not isolated because there's a radical beside it. So what happens here is that I can only isolate one of them at a time. And that's exactly what's required. You're going to isolate one radical. It really can be either one that you want. A lot of students will just kind of isolate the first one that they see. Now that means that I would have to subtract this root 2x to the other side. I know it's a little bit funny looking, but if you subtract it over, you get the square root of 2x plus 3 equaling 3 minus the square root of 2x. Now the whole reason that I did that was because I want to square both sides. Remember, when you square away, when you power away, you're going to be able to cancel that radical. That's easy, but on this side, it's a little tricky because now we have to square both sides like a quantity, like a FOIL method. Yep, you're going to have to do the FOIL method with 3 minus 2x. So, what do you think? Let's make sure we write down what happens on the left side. Again, that's kind of easy. But what happens here on the right side? Well, you're going to distribute once. 3 times 3, that's going to give you 9. You're going to distribute twice. That's going to give you negative 3 square roots of 2x. You're going to distribute a third time. That's another negative 3 square roots of 2x. And in the last one, you're going to distribute square root times square root. Now, that does come out to be positive, and if I'm allowed to get underneath there, I'm allowed to get 4x squared. But 4x squared, that can be simplified. That can be simplified to be 2x. That's because you can take the square root of 4 to be 2, and you can take the square root of x squared to be x. So what's kind of my final look here? We have this 9. The blue numbers are going to add together to be negative 6. and I got that 2x over there. Now, this equation, we're not done yet, but it's kind of like we're starting over. We're starting over with trying to isolate the new radical, in this case, the only radical that's left. Now, to isolate that, you can start moving some numbers away from it. You definitely can subtract 9 away from it, and you can subtract 2x away from it. So we're doing some things that are isolating the square root. But when you do that, over here on the left side, you end up with -6 because those 2x's cancel. On the right side, we're left with -6 square root of 2x. Now, if you divide your -6's, you're going to end up with 1 equaling the square root of 2x. And it's finally time to power it away. The whole reason we did this is so we could square both sides, so we could power it away. Of course, when you square the number 1, you still have 1. I'm going to switch over here, and now I have to solve for x by dividing by 2. Okay, a little trickier, but what you did was you squared both sides, but you had to do it one at a time. Now, if we were in class, it's a common question for kids to say, why can't I just square both sides right away? The problem with this is that you're actually doing a variation of a math teacher's nightmare, because what you're really saying to me is that you're going to square both sides, but you're going to try to distribute this exponent, which means kind of like squaring everything individually. You're not allowed to distribute an exponent over a plus sign or a minus sign, so you can't square both sides, and you definitely can't just kind of square everything. If you look that over, it is not going to give you the same result that we just got. It is not going to give you 1/2. Now, I'm going to save you the effort of checking that. I'll tell you that 1/2 does check. It is the correct solution. We got one more problem, and the problem is a rational exponent. Wait, who let the rational exponent in? Well, remember, a rational exponent is the same as a flower power, where the root is actually the denominator is actually the root, and the numerator is actually the power. Now, the nice thing about a numerator of 1 is that it really doesn't need to be written because it does not affect the problem. So what I can do here is I can change it to a radical so we can power it away. And we power it away with a 5. Not a 1/5, but a 5. And that gives us 3x minus 1 equaling. Now, what is 2 to the 5th power? Are you thinking about that? That's 2 times 2 times 2 times 2 times 2. And that should be 32. So after we add 1 to both sides and get 33, you can divide by 3, and 33 divided by 3 is 1. Now, you really should check your answer, but if you take the number 1 and you plug it back into the problem, you'll find out that it does work because, because 3 times 1 is 3, and all right, so the answer is not 1, is it? The answer is 33 divided by 3, which is 11. Now, if you check 11 back in the original problem, now I think we're going to have some better luck, because when you plug 11 back in, you get 33 minus 1. Of course, you're really doing the 5th root of that, and that's the 5th root of 32, which is going to take us back to the number 2. It does check. So did you see what we did? We changed to radical form to help us deal with that rational exponent. All right. Well, this is the last official homework assignment that goes with this chapter on radicals. You got 6 little problems here. I encourage you to solve them up. And I'll tell you what I'm going to do is at the end of this video, I'm going to show you the answers. And you may check those answers like you normally would check in class. All right, so the answers that you should be getting on this would be 16, 29. You should be getting 70 on this one, but I'll put a little question mark beside that. I'm sure you can guess why. how about this one? You should be getting x equals 1 and x equals negative 5, but one of those you're going to end up crossing off. You should get x equals 7 for this one, but again, we'll put a little question mark as you can work out the rest of that. And then for this last one, you actually will end up getting 4, and you will get negative 3, but one of those also you're going to end up crossing off.
Properties of exponents. Properties of exponents. Properties of exponents.